All right. So sign convention tells you, which side the positive and negative is. And when you talk about sign convention, you're talking about the rule to apply to the positive and negative sign measurements. And really, we had three rules. Number one, and actually, let me go ahead and do it on the other page. Now, these rules are actually three rules, which are number one, all distance measured from the pole, whether it's behind, why it's not writing like that, or front. I'll just write down of the mirror. So all distance measured from the pole, whether behind or front of the mirror. And let me just put this over here. Now, when we talk about pole, just a reminder, it's your center of your mirror. And when you talk about all distances, we're really talking about three main distance, which number one is how far is the focus, which is your focal length. Number two, how far is the object, again, from P. And number three, how far is the image that is forming. That was the first rule. Are you with me so far? You with me, Rachel? Looks like you're about to fall asleep. Swear to God, if you fall asleep, me and you are going to go have a fight outside. Don't fall asleep. Okay,
Still
good.
awake. Don't worry.
Number two, the direction of incident ray is going to be positive after the pole. And number three, your object or image is up when positive and down, or you can say inverted. If negative. So basically, these signs tells us what kind of mirror. It helps differentiate Then it's differentiate with an I. The measurements, mathematically. Now, for instance, a negative f, negative focal length, means it's a concave mirror. Where basically there's going to be a concave mirror. And let's say your object is over here. This is your incident ray. That means it's going to be positive. This is going to be negative. F would be like right over here, for instance. So then the distance for the F would be negative. So it's a concave mirror. Positive F means convex mirror. And I'll draw it over here. Uh, Same thing. Here's your convex. Let's say this is your F. This is your object, and here's the incident ray. This is going to be your positive. That's going to be your negative. So positive F, that means this distance will be positive. Means it's a convex, concave, sorry, convex mirror. If your image or object distance is negative, that means it's in front of your mirror. If the image or object distance is positive, that means it's behind the mirror. So the signs tell you where everything is at without having to do a lot of drawings. Are you with me so far? You good? Anybody writing? Okay. So let's say we have a concave mirror. So let's say we have a concave mirror like this. And here's our mirror. Here's our dull side. Here's our pole. Let's say F is over here. That's your focus, which is you got your focal length, and you got an object. This object is 6 centimeters from here to here. Technically, it would be from here to here. What a PS. Okay. Now here's my question. Where will the image will be? Right? Now here's the thing. When you're drawing this, it's not for scale. Are y'all with me so far? You with me, Meadow? Tara, are you with me? Antoinette? So this is not for scale, right? So having to do a lot of lines to figure out where the image is just gets a lot of headache and stuff. So basically, one thing we do not want, we do not want to draw too many lines. One thing is we do not want to do is we do not want to draw many lines. So what's the solution? So the solution is we're going to be introducing a master equation. Now, this master equation that we are connected, that we are going to be introducing will connect all three distances, your F, your O, and your I. You know what? I'm not gonna write O. I'm gonna write DO and DI, which DI is the image distance or displacement. DO, that's object distance, and F is your focal length, which is basically your focus distance. Now, the thing about this equations that that the mass equations that we're going to be introducing, this will work for all convex and concave mirrors. Okay, and this master equation that we will be introducing is going to be 1 over F is going to equal 1 over DI plus 1 over DO. DO is the object distance. F is the focus distance or your focal length. And DI is your image distance. So let me go ahead and write it down. So basically, it's 1 over F equals 1 over DI plus 1 over DO. Now, the thing is, this is a sign sensitive formula. What does that mean? When you talk about sign sensitive, it means we put signs where we sub numbers n. So going back to our example, where we got, again, you got your concave. I mean, I'm not even gonna do this. I'm just gonna go ahead and copy it. It'd be a lot easier. Copy. Paste. So for our example that we just started with, let's say our focal length let's say for this one was, did I sign the numbers? Oh, I did not even write that down. How much the focal length? Let's say the focal length over here. I'll just write it over here. Is let's say it's 2 centimeters from over here to over here. And again, our image is 6 centimeters. So basically, our distance of the image is how much? Well, basically, you got an object. Here's your dull. I'll go ahead and write it down for you. Here's your shiny side. You got your object. That means your incident ray is coming in this way, which is going to go through the pole. That means this is going to be your positive side. This is going to be your negative side. Are y'all with me so far? Everybody with me? All right. So you got your positive side on that side, your negative side on this. That means your distance of the object in this case will be minus 6 centimeters. Your focal length will be minus 2 centimeters because of the negative side, which means, let's say you want to find the distance of the image. So from these two, 1 over f equals 1 over di plus 1 over do. Go ahead and solve this, tell me what you get. See if you get the same answer as I do. So 1 over minus 2 is going to equal to 1 over di plus 1 over minus 6, which means 1 over d of I is going to equal to what? Minus 1 half plus 1 over 6. And over 6, what you're going to have? You're going to have plus 3. So not plus 3, minus 3. Is my math correct, guys? Are y'all with me? I
Yes,
got
it's
one
correct.
minus 1/3, right? That means my distance of the image equals minus 3 centimeters. So it will be, the image will be over here somewhere where this is going to be 3 centimeters. Does that make sense to everybody? Do y'all see that? And it's on the negative side. Y'all see that? Any questions? Cassian, you with me?
Yeah.
Awesome. Awesome. All right. Now, all right. So let's say, let's do another example, shall we? Let's say we have an example of, let's say we have a convex mirror where you got an object. This object, let's say, is 3 centimeters from the mirror. And it's creating an image. This image is, let's say, 10 centimeters. I can make this 30. It makes it a lot easier on calculations. So find your focal length. Go ahead and try to solve it. The first thing you do is you need to figure out which one's the positive, which one's the negative, right? So here's a mirror. That's dull. That's shiny. Ray, incident ray going in this way. That means it's going to come out this way. Here's your pole, P. That means it's going to be positive, it's going to be negative. So 1 over F is going to equal 1 over DI, O plus 1 over DO. And in this case, your 1 over F is going to equal to what? 1 over the distance of the image, which is going to be what? No, let me actually go ahead and write down the information first. All right, so you got your distance of the image, which is going to be on the positive side, so it's going to equal to what? 10 centimeters. Distance of the object is going to be on the opposite side, which is going to be negative 30 centimeters. And again, from these two, 1 over F is going to equal to 1 over DI plus 1 over D of O, which means the 1 over F is going to equal to 1 over DI is positive, so it'll be 1 over 10 minus 1 over 30, which means that 1 over F is going to equal to over 30. So you get 3 minus 1 is 2. So you get what? 1 over 15, which means that the focal length is 15 centimeters. You have to flip it. And it's positive. So that tells you that the focal length is going to be, if this is 15, so it'll be, maybe like somewhere around here, where this whole thing is 15 centimeters. Everybody with me so far? Donate, you with me? Nathaniel, Marah, Meadow. All right.
I'm with you.
Oh, Jangir joined us again. Okay. So let's do another example, shall we? All right. So let's say you got a concave mirror. Here's your pole. Here's your object. Well, let's say your object is 12 centimeters. And here's your focus, which is 15 centimeters. Let's say here's your center of curvature. Okay. Find the distance. Where is the image? Find the distance of the image. Okay, don't wait for me to start doing it. Go ahead and do it for yourself. Try to figure it out first. What's the first thing you do, guys? You see what your positives and your negatives are. So here's your image. Here's your mirror. That means this is the dull side. Here's your shiny side. You shine it on the mirror. So it goes in, boom, this way. That's your ray, your incident ray. That means this is your positive. This is going to be what? Your negative. That means your focus, it'd be in the negative side, be minus 15 centimeters. Your distance of the object, it'd be on this negative side, be what? Minus 12 centimeters. This is for the image, right? So that means 1 over F equals 1 over D of I plus 1 over D of O. Which means 1 over minus 15 is going to equal 1 over the distance of the image that we're looking for, plus 1 over minus 12, the distance of the object. That means 1 over D of I. Anybody got an answer? That's supposed to be easy stuff. That's all like algebra.
Is it
Anybody got an
60?
answer? Huh?
Is it 60?
Yeah, exactly. That's correct. So DI equals 1 over 12 minus 1 over 15, which in this case would be what? 3 over 180. That means D of I equals 180 divided by 3, which equals 60 centimeters. That means, and it's positive. That means the image will be like right over here somewhere at 60 centimeters. Are you all with me so far? You with me, Meadow? You got it? Okay, let's do another example, shall we? Now let's say, and go ahead and write down the information first. So let's say you got a concave mirror. Here's P. Here's F. That's my object. Let's say the distance for F is 21 centimeters. And let's say again, image right over here. And the distance for the image is 56 centimeters. That's image I. So find the distance for the object. So if you write down the information again, this is your dull, this is your shiny. So the first thing you do is you write down where your positives and your negatives are. So basically, you're getting here's the object, here's your shiny. That means you're getting a light over here. That's your ray. And it's gonna head over here. It's gonna go through the P. So that means that's your positive, that's your negative. Are you all with me so far? Okay. Again, so that means your distance for the image will be what? Negative 56 centimeters because it's a negative side. See, here's your negative side, here's your positive side. That means the focal length in this case would also be negative, which is going to be negative 21. You find you want to find the distance of the object. From these two, 1 over F equals 1 over D of I plus 1 over D of O. That means 1 over minus 21 is going to equal to 1 over D of I plus 1 over minus 56. Anybody solve this? Where's all my algebra people at?
I'm not sure if the sign threw me, but I got negative 33.6.
That means the distance of the object in this case, or the image, not the object, the image. Dude, well, it's the same thing. It's the same thing, really, mathematically. I just did them oppositely. This is the object minus 56. That's better. Same thing. It's just, I like them be organized. That means the distance 1 over DO is going to equal to 1 over 56 minus 1 over 21, which is if you multiply them both, what you get? 56 times 20. So 50 times 20, that's 1,000. And you get the 6, it's 121. And then you got the 1, it'd be what, 50? So you get what, 1176? Is that right?
Yeah.
Yeah, who needs a calculator, man? 1176, that means what? You give me 21 minus 56, right? And what you gonna get? Minus 35 over 1176. That means the distance of the object it'd be 1176 divided by 35, and don't forget the negative. And you should get how much you said you got? How much you said you
It's
got?
Negative. I got negative 33.6.
Sure.
so did I.
Well, let's see. That by 35. And guess what? You are right. Centimeters. And it's centimeters because of the distance. Are you with me so far? Everybody understand it? Oh, cool. All righty. Okay, well, let's do another example, shall we? Let's say an object is placed 1.5 meters in front of a convex mirror of focal length 1 meter. Find the distance of the image. So again, you got a convex mirror. Convex. Actually, let me do it over here. Convex. It's opposite concave. That means this side is the dull side. An object. So you got an object over here that is 1.5 meters. Okay, let me write down over here. From over here to over here. And because of the convex, that means you get a ray coming in this way. That means this is going to be your positive, this is going to be your negative, right? And your focal length is 1 meter. So let's say here's your F, which is 1 meter. So basically, your D of O would be what? Minus 1.5 centimeters. Your focal length is in the negative, be minus 1 meter. Oh, I'm sorry. Hold on. I made a little mistake, guys. It's in the positive. F is in the positive 1 meter. It says so in the positive. Positive 1 meter. And you're looking for D of I. And you know 1 over F equals 1 over D of I plus 1 over D of O, which means 1 over 1 is going to equal to 1 over D of I, the one we're looking for, minus 1 over 1.5, which is your D of O. Which means solving this, 1 over D of I is going to equal to 1 plus 1 over 1.5, which is 1 plus 1.5 is 3 over 2, opposite, which in this case is 3. So you get what, 5 over 3? What's 5 over 3? Anybody solve it? Anybody solved it? I get 1.6. That means D of O equals 1 divided by 1.6, which is 0.6 centimeters. And it's positive. So in this case, your image would be right over here somewhere. Anybody confused yet? Cassiano, you're good? Nathaniel,
Yeah.
good? Nathaniel's not here. He's like watching TV. Are you good? Tara, you good?
I'm
I'm okay. I converted it to centimeters. I don't know why. I just didn't think
Say that
I'd be
again.
able to do it with
Where you
meters.
lost that?
I converted the distances to
You don't have
centimeters.
to.
I
Just
don't
it's always in meters anyway. So 0.6 centimeters times 10 negative 2. So just keep it in meters.
Okay. But I feel like
Yeah.
if I
I'm sorry.
converted it to
Did I
centimeters,
just say 9.6 centimeters? That was my bad. I know you get confused. D of I equals zero point 0.6 meters. Is that better?
yeah, but I feel like if I converted the values to centimeters
It's
and
the
then
same thing.
converted it back to meters, I should have still got the same answer, but I got something different.
Yeah, you did something wrong.
Okay.
Sorry. Here, let me give you another example, and you go ahead and
Okay.
try it. Okay.
Okay.
Uh, Actually, my next one is going to be the magnification. Uh, Here we can do this one. So let's say you get object is 3.5 centimeters or meters, whatever you want to do. Let's do centimeters. 3.5 centimeters from pole on uh concave mirror. Focus is at 2 centimeters. Find the distance of the image. So again, you got a concave mirror. Here's my concave mirror. It's like a cave, so the cave part is the shiny. Here is my object, which is a 3.5 centimeters from over here to over here. This is my object. And let's say my focus is over here. That means your focal length is 2 centimeters from here to here. Find the distance of the image. Again, first thing you do is you sign up your ray. So this is your ray coming in, your incident ray. You're gonna come in through the pole, P, that's where it splits. Here's your positive, here's your negative. That's your negative, that's your positive side. That means your focal length is minus 2 centimeters, and your distance of the object is minus 3.5 centimeters. From these two, what you get, 1 over F equals 1 over D of I plus 1 over D of O, which means that 1 over D of O equals 1 over F minus 1 over D of I, which in this case, it'd be 1 over minus 2 minus, oh, I'm sorry. d of I equals 1 minus d of O, which is minus 1 of 2, minus 1 over minus 3.5. Which means that 1 over d of O, let me get a different color. 1 over d of O is going to equal to, it's what, 7? 3.5 times 2 is 7. So times 2, what'd you get? To multiply this by 7, it'd be what? Minus 3.5 minus, and then to make this into a 7, you multiply it by negative 2. So multiply this by negative 2. Is my math correct? So what'd you get? Minus 1.5 divided by 7. That means your d of O equals 7 minus 7 divided by 1.5, which equals to what?
I
Point
got
6,
negative 4 point. Yeah,
which is going to be like right over here. That's where your image is going to be. Are you with me so far? Does that make sense? Ain't that easier than drawing lines? Are you with me?
Yes.
Awesome, awesome. Okay. Now, notice one thing when we're actually doing this. What about the image that we're doing? When we did this, we did how many examples? 1, 2, 3, 4, 5, 6 examples, right? We just did 6 examples. Are you all with me so far? Notice what about the image? What's about the image? What do you notice about the image?
are they virtual images?
Or you know what? Which way are they going? Up or down? How would you know? We don't, because here's the thing. This formula that we have only tells you how far the image is. Doesn't tell you if the image is up or down, inverted, or how tall the image is. Does that make sense? Are you with me so far? So I don't know how this became unmute. So when we use the mirror formula, which is 1 over f equals 1 over d of I plus 1 over d of O that we've been using. When we use the mirror formula, notice that there is no HEIGHT at all. It just tells you how far is it. So basically, it's only useful for how ah useful. So for how far the image from the mirror or the pole, not how big is the image or that we're getting. So basically, we need another formula for the height. And this formula that we're going to be introducing right now, ladies and gentlemen, boys and girls of all ages, is called the magnification formula. And the magnification formula tells you that your HI over your HO is going to equal your DI over what? Your D of O. HI, that's your image, HEIGHT, and this is your object, HEIGHT. This is your image distance. This is your HEIGHT distance. Notice, so when you get the height of the image over the height of the object, this is going to be your ratio of your height. And if you take this little fella over here, this is the ratio of your distances, where this is going to be equal. So basically, the ratio of the height equal the ratio of the distance. So basically, your ratio of HEIGHT is going to equal the ratio of your distances. So basically, again, your HI over HO is going to equal DI over D of O. So this is going to be your magnification formula. Now, in the magnification formula, let me just, I'm going to go ahead and take this little side, this little fella. We're going to take the left side. And you know what? I'm going to write it over here. Take the left. We're going to take the left side, which is basically your HI over HO. Now, what is this formula called? What is this formula called, guys?
Magnification formula.
Magnification formula. Okay. The magnification part is this little fella, the first side, the left side. So this side is called your magnification. Magnification. Which is basically your ratio of HEIGHT, which you give it a big letter M. So basically, M is going to equal your HI over your HO. So the first part is called your magnification. Uh-oh. Do not tell me you crashed. Okay, good. So when you talk about magnification, take take the left side, which we're gonna call magnification. It's that little black. So your M equals HI over HO. Are you all with me so far? Are you all with me? Okay. So if I actually write it down, that means the height of the image is going to equal to MH naught. For example, if I tell you HI equals 2HO, what does that mean?
The ratio of the image height to the object height is 2 times 2.
Yeah, times two. That means is it bigger or smaller, the image?
Bigger.
Bigger is twice the size. Does that make sense? It tells you how big the image is or how small it is. Does that make sense, everyone? That's awesome, right? So when you say HI equals HO, that means HI equals MHO. This is your magnification over here, right? So M equals 2 means that HI equals 2HO. Now, M is actually, let me get a different color on this. So now your magnification is sine sensitive. Actually, let me write down. Let me just write down. Let me just write down over here. So basically, magnification means it is sine sensitive. So magnification is sine sensitive. What does that mean? When you talk about sine sensitive, it means what? It means if the magnification is positive, that means, again, think about it. If this was positive, that means these two have the same sign. Does that make sense? Whether they're both negative and they're both positive. Does that make sense? That's how magnification gets positive. Does that make sense? If HI or HO, one of them has a different sign, you're going to have a negative. So if M is positive, it means HI and HO have the same orientation. have the same sign orientation. Which means that the image is virtual. If M is negative, that means you're using a screen. That means the image is real. So if your M is negative, HI and HO are different signs. That means the image is inverted. When you get an image inverted, that means it's a real image. Okay? For example, if you say your magnification is minus 0.3, and again, it's a ratio, so there is no unit for magnification. Let's say it's minus 0.3. What does that mean? This means that h of I is going to equal to minus 0.3 h of O. The height of the image has the opposite sign of the height of the object, which means because M is negative, that means HI and HO are inverted. I'm going to call it inverse. Are inverse, that means the image is inverted, which means it's a real image. So your M is minus 0.3. That negative that you see on the magnification tells you it's a real image. If it's positive, it's a virtual image. And the 0.3 is telling you it's a smaller than the object. Smaller than the object. Everybody understand magnification right now? Okay, so let's do an example. So let's say you got a mirror. This is ugly. Here's your P. Let's say you have here's your object over here. And again, let's say 6 centimeters. All right. So you got the object over here is gonna be at 6 centimeters. Okay, so this object is 6 centimeters. Let's say, again, let me go. My focal length is over here, and this is going to be 2 centimeters. And let's say I got an image right over here at 3 centimeters. The magnification that we have in this case, it'd be what? HI over HO. And again, you can always say it equals minus DI over DO. Did we just put the minus in when I wrote the magnification equation? Oh, I'm sorry. I knew I forgot to do something. Don't forget the negative. HI over HO equals minus DI over DO. All right. So again, this is your M. This is so basically, let me go ahead and write down the magnification equals minus DI over DO. And in this case, our magnification will be, again, you get your ray coming in this way. That means it's going to be your positive. What? How did that change? That means it's going to be your positive. It's going to be your negative. Right? So in this case, what are we going to have? You're going to minus DI. The distance of the image is 3. Should be negative 3 divided by the distance of the object, which is 6 to the negative side, be negative 6. So what you get, minus 1/2, or you can say minus 0.5. This minus 0.5 is going to equal, this is the minus 0.5 over here, is going to equal minus DI, sorry, not DI, the height of the image divided by height of the object. That means the height of the image, in this case, it'd be minus 0.5 times height of the object. Whatever the object is. So basically, this means if HO was 10 meters, the HI is minus 5 meters, which is going to be inverted. If HO is 8 meters, that means HI is going to be half of before meters. Are you all with me so far? So let's do an example.
Can you go back to that slide really quickly?
Are you all with me so far?
Yeah.
So if this is, let's go ahead and write this down. Let's say if this was 10 meters, you're going to have an inverted image. There's going to be 5. Well, we're doing centimeters, so I'll just do centimeters. 10 centimeters, that means there's going to be the height is 5 centimeters. Does that make sense? And don't forget the negative. Okay, you give it up?
Is that, yeah, does that say 8 meters?
Yeah,
What does
if
that
it's
say?
8 meter, that means the other one's 4. Does that make sense?
Okay.
8 meters, that means 4 because it's one half. Does that make sense? The image is
Yeah.
half of the object. So in this case, for example, you got an object is at 18 centimeters in front of concave. The image height is 4 centimeters. Now this is going to be inverted at a distance of 14.4 centimeters from the pole. Find HO. Go ahead. I'll give you all a couple minutes to do it. All right. Everybody finished? Anybody got an answer for me? So basically, and again, this helps you out with just the drawing. It's a concave mirror, so here's your mirror. It's concave, so here's your dull side. Here's your P. You got an image height. So you got an object over here. This object has a ray. And you got an image height that's inverted. So it's inverted over here. That is going to be 14.4 centimeters this way. And this is going to be 4 centimeters. And it's 18 centimeters. We said 18, how much? Hold a second, not 18 centimeters. What am I talking about? Yeah, I forgot to write the distance of the object. My bad. 18 centimeters. So basically, let me go ahead and write it down. Again, this is going to be your positive. This is going to be your negative. You got your distance of the object is minus 18 centimeters. I forgot to give you all the 18 centimeters. My bad. Your distance of the image is minus 14.4 centimeters. And your height of the image is going to be minus 4 centimeters because it's inverted. You're looking for the height of the object.
I got 5 centimeters. Would that be right?
Yeah, that sounds right. Let me just check.
Okay.
So,
So you have the image distance or the object distance is
yeah,
14.4 over 18,
let
right?
me go. Yeah, so the magnification. Okay, correct again. So your magnification in this case is minus di over do, which is we already got di minus 14.4 divided by do, which is minus 18. And again, this is going to equal to hi over ho, which means that ho, the height of the object that we're looking for, is going to equal to the height of the image times negative times, well, the negatives cancel out, two of them. Anyway, this one cancel out with this one. So it'll be, okay, it'd be ho times negative 14.4 Although I'm confusing myself. HO is going to be. Yeah, that's correct. It'd be HI times 18, negative 18 divided by 14.4, which is going to be negative 4. That's negative 18 over 14.4. And you should get, what's 18 times 4? I should know this. 72. So it'd be 72 divided by 14.4. $72 divided by 14.4. And we got plus 5 centimeters. So basically, this one would be right over here. Oh, sorry. This one will be 5 centimeters. And notice it's positive, so we are on the right track because it is up. Does that make sense? Are you with me so far?
Wait, why is 14.4 positive now? Oh wait, never mind, I see.
Yeah, I just canceled that negative. I just moved the negative up. Does that make sense? You got it? All right.
Yeah.
It's really easy. Once you do the signs, it's really easy where which way to go. So let's just do another example, shall we? Let's say let's say here's another example for you. Okay. So your object of length 5 centimeter is this placed at 50 centimeters in front of your convex mirror. It forms a 2 centimeter image. Find the distance of the image. And again, it's like you read it. So first of all, you got a convex mirror. Here's your convex mirror. That means the object has to be over here on the shiny side. The object is 15 centimeters. That's your object. Again, you get your light over here. It's coming in this way, so that's your positive, that's your negative. The height of the object. 5 centimeters is positive, so it's going up. And the height of the image is 2 centimeters. So the height of image is 2 centimeters. That means the image is going to have to be over here at 2 centimeters. This is the height of the image. So basically, let me go ahead and write them down. Your distance of the object is minus 15 centimeters because it's the negative side. Your height of the object is 5 centimeters because we're going on top. Your height of the image, we said, is going to be 2 centimeters. And find the distance of the image. Again, happy to use the equation. HI over HO equals minus DI over D of O. That means D of I is going to equal to minus HI D of O over HO. So this will be X equals to what? Minus HI is 2. D of O, the distance of the object, is minus 15. Divide that by 5. And what you all should get? What is this? 5 divided by 1, 5, and this is 3. So what you get? Plus 6 centimeters. So the distance of the image is 6 centimeters and it's positive. So it's on this side. Do y'all see that? Does that make sense, Rachel? Are you lost? Are you lost?
Slightly, but I usually read after and it helps. So I'll find the plot again.
Okay. Well, if you have questions, I'm over here. The main thing is you all notice we just have to know what the positive and negative is, right? Does that make sense? Okay, let's do it again. Let's do another example. Here's an example for you, Rachel. Let's say your HO is minus 4.5 centimeters. And your HI is 14.4 centimeters. Find the magnification. What? You gotta put the magnification. Anybody got it?
Negative 3.2.
Yeah, 3.2. Is that right? Is that right? Is that what you got?
I got negative, but
Negative. I was waiting for somebody because the 14, this is gonna be negative, so this is gonna be what? Negative. That's correct. I was waiting for somebody to tell me the negative part. Okay. Here's another question. Okay, let's say your HO is 3 centimeters in front of your concave mirror. Find HI. Find the height of the image. And this is find the hammer image where the distance of the image is 48 centimeters. And your focal length is 12 centimeters. So basically, it's a concave mirror. Here's our concave mirror. This is our object, somewhere around here. And you got, this is going to be 3 centimeters. No, this is going to be 3 centimeters. Hold on, I forgot to give you the distance of the object too. Okay, that makes sense. So here's your object. It'd be what? 12 centimeters distance. You got, that's your image, which is a distance of 48 centimeters. That's the height of the object is 3. We need the height of the image. Okay, and the focal length. I'll say right over here. I am such a, swear to God, I am getting tired. Not the focal length is DO equals 12 centimeters. I knew something was wrong. Okay, so you got your image object, your object is 12 centimeters away from the mirror. with a height of 3 centimeters. The image distance is 48 centimeters with a height that we need to find, and your focal length is over there. So let me go ahead and get a new page. Your magnification is minus di over d of o, which is in this case d of I is going to be, so again, you're getting a ray this way. That means this is going to be your positive. This is going to be your negative. That means this is the image be minus 48 centimeters. Your distance of the object is minus 12 centimeters. Your height of the object is 3 centimeters. Your height of the image, that's what we need to find. So your di over do would be minus 48 divided by minus 12. Again, this is going to equal to minus d of I or d of o. Not that. Wrong one. I'm sorry. Equals HI over HO because let me go ahead and write down the equation. M equals minus DI over D of O, which equals the ratio of the heights. So in this case, the height, and we're looking for the height of the image. It was going to equal to H of O. Again, these two is going to cancel out. We're going to be H of O times 48 divided by, I'll just put a negative in the bottom, negative 12, which equals to 3 times 48 over negative 12. Divided by 3, you get 1. Divided by 3, you get 4. 48 divided by 4, which is going to be what? Negative 12 centimeters. So your image is inverted and is going to equal to minus 12 centimeters. Are you with me so far? So when you say M equals, let's say, negative 0.4, this means that the image is real and inverted. Basically, it's going down. When you say, let's say, M equals 0.3, then the image is real and inverted. I mean, if it's positive, I mean, the image is virtual. And pointing up, which also means it's smaller. Let's say M equals, I don't know why I'm doing small m. It's supposed to be capital M. Let's say M equals 1.2 negative. That means because it's negative, it is a real image, bigger in size. And inverted.
Why is it bigger in size? Because it's a larger number?
Yeah, so what did we say? We said, let me just give them different screen. We said that the height of the image equals MHO, right? You with me so far, Meadow? Right? If M was 0.1, 0.5, or 1.2, so it'd be 1.2 HO. That means if the height of the image was 10, this is going to equal to what? 1.2. Sorry. If this was, let's say 10, that means the height of the image is going to equal 1.2 times 10, which equals to 12 centimeters. Does that make sense? If you do, let's say this is M equals 1.2. If M equals 0.6, the height of the image is going to be 0.6 times height of the object. So let's say this little fella right now is still 10. That means the height of the image is going to be 0.6 times 10, which is going to equal to 6 centimeters. You see that? Magnification is smaller, that means the image is smaller. When it's higher, that means the image is higher. Negative, positive just tells you what direction it is. You with me so far? Cool. Okie dokie. Let's do an example. And go ahead and try to do this on your own, guys, real fast. You got a concave mirror. Produce an inverted real image on the screen. Eight centimeters in front of it. Now your image size is 4 times bigger than the object. Find the focal length. So again, concave mirror. Concave, here's my cave. Here's my dull side. Here's my P. Here's my object. That means the ray is going this way. It's going to go through the P. That means this is your positive. This is going to be what? Your negative. Okay. So what do we have? You have your distance. So it says a mirror produces a inverted real image, 8 centimeters, right? Uh, let's see, here's my object, and here's my image. And the image is inverted at a distance of 8 centimeters. So your distance of the image is 8 centimeters, and it's a negative side, so be in the negative. Your magnification is 4 times bigger, so be minus, and it's inverted. So be minus 4. And from this, HI is going to equal to minus 4 HO. Now we need to find F. So we're looking for your focal length. And we know that 1 over focal length equals 1 over DI plus 1 over D of O. So we have D of I, we just do not have D of O. So we need to calculate this little fella. So D of O. Oh, we need to calculate D of O. Okay. And from this one, we know the magnification equation is x minus di over d of O, which means that d of O is going to equal to minus d of I over the magnification equation, magnification, which is going to be minus 8. So minus 8, negative 8 divided by negative 4. Again, negatives cancel out. And 8 divided by 4 is 2, to be negative 2 centimeters. So your distance of the object equals minus 2 centimeters. That means, in this case, 1 over f is going to equal 1 over minus 8 plus 1 over minus 2, which is going to equal to, I don't like the way I wrote negative 8 on this one. Which, if you do it, what you get? Over 8. What you get? Divided by 1, it'd be 1. To get it 8 is negative 4, so it'd be negative 4, be minus 1 minus 4, it'd be minus 5 over 8. Is that right? That means f equals 8 divided by negative 5, which equals, in this case, it'd be minus 1.5 centimeters. That means it's going to be on the negative side. Here's your f, and it's going to be 1.5 centimeters, and it's on the negative side. Okay, let's do another example. Let's say you have convex mirror. Convex mirror of length 8 centimeters. Now, this mirror forms virtual image. Three centimeters behind it. Find our magnification. Okay. Again, it's a convex mirror. Here's my object. That means he's my ray. It's going to go in here. That means this is positive. This is my negative. Okay. I forgot to put F. F is 8 centimeters. Find the magnification. So F is over here, which is 8 centimeters. So your F is going to equal negative 8 centimeters this time. Your D of I is going to equal, we said it's going to be 3 centimeters. So here's your D of I. And it's not inverted. We need to find M. And so in order to find M, we need HI over H naught, which is minus DI over D naught. We have DI and we have the focal length, but we do not have D naught. So we need to find D naught. So 1 over F is going to equal 1 over di plus 1 over d of o, which means, again, we want to find this little fella. 1 over d of o is going to equal 1 over f minus 1 over d of I. And this gets to be 1 over 8 minus 1 over 3. You should get what? Minus 5 over 8 times 6, 24. Is that right? It's 8, not negative 8. Which means that the DO would be 24 divided by 5. Negative, don't forget the negative. And you should get, it's almost to 25. 25 divided by 25, that's what? 5. So what? 24 divided by 5. You get minus 4.8 centimeters, which means when DO equals minus 4.8 centimeters, that means the magnification equation, which is minus DI over D of O, is going to equal to minus, which is DI is 3, minus 3 divided by minus 4.8, and we should get 3 divided by 4.8, 0.6 positive 3 magnification. Everybody so far?